Hi guys, so you're already rock stars at a lot of kind of factoring. So you know you've done greatest common factor, you've done factor by grouping, you've been done factoring trinomials. We just covered the difference of two squares, and now we are going to do the sum and difference of perfect cubes. So if we go ahead and look at this, we first want to figure out what are the perfect cubes. So take a calculator, do 1 to the third, you get 1. 2 to the third, you get 8. 3 to the third. Did you get a calculator? Are you doing them? Okay, 27. 4 to the third, 64. 5 to the third, 125. Now, to be fair, these are probably the ones you have to memorize because you have to know them right away to identify that they are perfect cubes. These later ones, you should kind of know and recognize they're perfect cubes. So 6 to the third is 216, 7 to the third is 343, 8 to the third, 512, and 9 to the third, we've got 729. This one, 10 to the third, you should for sure also know by heart, and it's 1,000. Okay, so when we factor the sum or difference of perfect cubes, you'll see here this is the formula we're going to use. So we have some quantity to the third power plus or minus some quantity to the third power, and it's always going to equal a either plus or minus b times a squared minus or plus ab plus b squared. So you'll notice that I've got two signs here, and basically when it's plus we're going to follow the top signs, and when it's minus we're going to follow the bottom signs. And you'll see this only has a one sign here, and that's because that one's always plus. So in your notes, basically for the sum, this is what you'll have, and then for the difference, this is what you'll have. Okay? All right, so you might be thinking, that's a lot. How am I ever going to remember that? I've got an acronym for you, SOAP. S stands for the same sign, O stands for opposite sign, AP stands for always positive. So you'll notice here, whatever sign you have here, the first one will always be the same, the second sign will always be opposite, and the last sign will be always positive. SOAP, same, opposite, always positive. So here's another way that you can remember it, and it's a song. I'm going to suggest that you sing along after the first time. First times first is first, last times last is last, first times last is in the middle, isn't this a blast? The first sign's from the problem, the second it's reversed, the third is always positive no matter what the first. First times first is first, last times last is last, first times last is in the middle, isn't this a blast? The first sign's from the problem, the second it's reversed, the third is always positive no matter what the first. I strongly suggest that you go ahead, rewind, and sing along 2 more times so that this song is in your mind as we go on to our examples next. So I've been talking for a minute, I've sang a song, but you might be thinking, how do I do this? So let's try some examples. The first thing you need to do is recognize that these are perfect cubes. That's why we listed the perfect cubes at the beginning of the lesson. So 27 is the same as 3 to the third power. So I'll go ahead and write it as 3 to the third power so I remember what I'm working with. Now, in terms of following the formula, I'm going to have in this first parenthesis the a and the b. So you want to do the cube root. So I'm going to have just x here, and this was 3 to the third, so I'm going to have just 3 here. I recommend that you use the song because the song will get stuck in your head forever, and you will be awesome at the sum and difference of perfect cubes. So I'm going to go ahead and sing as I go, and I'll explain each step. So I first have to start by figuring out these two numbers. Then I'm ready to go. First times first is first. So first times first, x times x is x squared, and it goes in the first spot of our next parenthesis. So first times first is first. Okay? Last times last is last. So last times last, 3 times 3, it's 9. That goes at the end. First times last is in the middle, but you guys know, x3, that would look funny. So I'm going to do 3x, since the order of multiplication doesn't matter. Isn't it a blast? Okay, now I'm ready to do the signs. The first sign's from the problem, so this is plus. The second, it's reversed. The third is always positive no matter what the first. And there you go. You've got the factored form of x to the third plus 27. Now, if you want to check your work, here's what you do.